In this video, we will be constructing an irregular polygon and analyzing its rotation at 180 degrees and its reflection. The target range for this video is NC Common Core Math 2, which is 9th through 10th grade. The purpose of this activity is to use the dynamic geometry tool, the Geometry Sketchpad, which I have available on my screen, to help in the investigation of the question located here in the top left-hand corner. Two Common Core math standards that align well with this activity would be 1. Use geometric descriptions of rigid motions to transform figures and to predict the effect of a given rigid motion on a given figure. Given two figures, use the definition of congruence in terms of the rigid motions to decide if they are congruent. And 2. Given a geometric figure and a rotation, reflection, or translation, draw the transformed figure using graph paper, tracing paper, or geometry software, and specify a sequence of transformations that will carry a given figure onto another. Let's begin by looking at the question I mentioned earlier, and it says, construct an irregular polygon and label its vertices. Find the image of that polygon under a 180-degree rotation. Create a mirror line and apply a reflection to that same original polygon. Is it possible for the image of the polygon after a rotation to correspond to the image of that same polygon under reflection, and explain? Before I go any further, I would like to mention the definition of an irregular polygon. That way it will help us to construct one and also help us in our investigation later on. A polygon that does not have all sides equal and all angles equal is an irregular polygon. So let's go ahead and construct our irregular polygon. And I'm just going to construct some random figure that looks like this, okay? So now I'm going to connect it by segments. Okay, so now I've done that, and it says that we need to label each vertice. So I'm going to re-label these. I was on here earlier, and that's the reason why they're kind of funky. So I'm going to make this A, this B, this C. Oh, come on. Okay, this D, this E, and this F. Okay, so now all of them are labeled, and I'd also like to find the measure of each one of these lines to make sure that they're not the same, and that way we can confirm that this is in fact an irregular polygon. And it doesn't look like any of them are the same. I'm going to move this one in a little bit. Still none of them are the same, but it looks a little better there. Okay, so now we have a irregular polygon. It's labeled. Now it says find the image of that polygon under a 180-degree rotation. So I'm going to use point or vertex D here, and this is going to be our center marker for what we are going to rotate our figure around. So to mark that vertex D, we're going to hit transform, hit mark center. So you saw it explode, and that means it's set. So now I'm going to highlight this whole figure, and I'm going to hit transform, rotate, and then it's already put in at 180 degrees, so I'm just going to hit enter, and that's going to rotate it. So now you can see our rotated figure at 180 degrees around this center point right here. Okay, so now I'm going to draw, it says create a mirror line and apply a reflection to that same original polygon. So I'm going to hit the segment button. I'm going to create a segment that goes down through here. I'm going to move it just a little bit. Get it on that center, in the center there. Alright, there we go. So now it's highlighted. I'm going to hit transform and mark mirror. You see it exploded, so that means it's set. So this is the original figure that we want to reflect over this line here. And we're going to see if we reflect it if it's possible that after the rotation and after the reflection, if they correspond together. So pretty much if they're the same. So I'm going to hit transform, reflect, and we can see that these images are not the same. So when we rotated it 180 degrees, it left the figure one way. When we reflected it, it kind of flipped it. So yeah, they're not the same. And I believe that this goes back to our definition that said an irregular polygon is one that the sides are not equal and the angles are not equal. And in that case, none of the angles or sides are congruent, and there's no symmetry within this figure. And therefore, when you rotate it, it doesn't stay the same. It kind of flips a little bit, so when you reflect it, it's not going to look the same either. To make this point a little more clear, and this goes for any irregular polygon, I can draw another quick polygon or irregular polygon really quick, and this can be just a simple triangle that looks like this, because we know that all of these sides are not equal. So if I just for time being, I'm not going to label the vertices, but I'm going to mark this point here as the center. I hit transform center, and then I'm going to highlight this whole figure and hit rotate, and that's rotated at 180 degrees, so hit rotate, and now it's rotated. Construct a segment. I'll fix this a little bit. Alright, there we go. And then I'm going to highlight this, mark mirror, I'm going to highlight the original figure. Alright, hit transform, reflect, and we can see that again, it's not going to reflect and be the same figure after rotating and after reflection. So I don't believe it's possible with the irregular polygons, and I believe it's because there's, again, no congruence and no symmetry. I have another page pulled up, and I'm going to pull it up now, and this is a square. Okay, so a square is a regular polygon. And a regular polygon states that all sides are equal and all angles are equal. So it's just opposite of what an irregular polygon is. And as you can see, I've already reflected it. Or not reflected it, I'm sorry. I've already rotated it 180 degrees. And I've already got the segment here. So that we can hit transform and mark the mirror of the segment. And now I want to reflect the square over that mirrored segment. So I'm going to hit reflect, and we can see that's the same exact figure reflected. So that shows that a square has symmetry, a square has congruence. So when it's reflected or when it's rotated, it will be the same. So that's the difference between it and the irregular polygon. So hopefully that made sense to y'all, and thank you for watching.